without further ado, we'll start with a video speech from Simonetta Cheli from ESA, and afterwards will be followed by some words from Daniel from the European Commission.
Welcome to the yearly user review meeting of the topic Copernicus Data Space Ecosystem. Today we gather to celebrate the remarkable success and rapid growth of CDSE, a testament to the power of collaboration and innovation. With over 500,000 users and counting, CDSE has become an indispensable tool in the Earth observation and in the domain in Europe and worldwide. Our ecosystem is a unique and the largest repository of publicly available EO products, currently 92 petabytes and growing at a pace of 1 petabyte per month, while being constantly updated with data from Sentinel missions, Copernicus services data and products, Copernicus contributing missions, and many more complementary data. This vast collection of data is instrumental in advancing climate science, sustainable management of natural resources. CDSE plays a crucial role in pushing technology and standards forward according to the FAIR principles. The unified and standardized API, scalable IT infrastructure, and the adoption of the standards like STAC. And thank you to that, we are setting the stage for increased data knowledge sharing. Moreover, CDSE contributes to the building of the digital sovereignty of Europe. With 2 European cloud providers, we have established the largest EO data hub with AI capabilities, fostering autonomy, resilience, and market development. CDSE is not just a repository. It is a thriving ecosystem that continuously evolves to meet the needs of its users. The ecosystem is opening, offering chances for data and service providers to become more visible, grow the business, reaping the benefits of foundation of the Copernicus data space. For example, we are in the process of onboarding the new space companies. The first Copernicus services data from the land monitoring services have been officially onboarded. It gives a primary example of how data access and its many forms become more unified towards the community. Furthermore, the European institutions are starting to build their workflows and application with successful examples such as Eurostat, paying agencies as well. We call upon European institutions, including the scientific communities and others, to build big things together with this. Focusing on reusable workflows demonstrated by successful collaboration with Eurostat and paying agency, we can achieve even greater heights. Let's continue to push the boundaries of data, technologies and standards together. So thank you for being a part of this review meeting, for your feedback and further improvement to the growth of the Copernicus data space ecosystem.
Thank you very much. So a few words from me. I'm Daniel Quintart, working with the European Commission and working on the CDSE with the colleague from ESA and of course the consortium, also the colleague from JRC. Copernicus, I was told when I started, Copernicus is user-centric. The opinion of the user are absolutely key, and therefore what's happening today is really important. Having the feedback from the users to remark what works, what does not work, where you would like to have, what you would like to have, is absolutely essential for moving ahead and providing the service that's needed. So first of all, a big thank to all the users that have been providing their opinions, remarks for this. And thank you for the CDSE consortium to organize this, because really it is key. There is a lot of information that has been provided. It's needed to move ahead and to provide the services that are needed. User-centric, also sustainable. Copernicus aims to be sustainable. We have been providing, of course, with the partners, ESA and the other partners of Copernicus, we have been providing Sentinel data and also Copernicus information extract from the satellite. So sustainability is the program. It's something we ensure and we want to push. And this is why there's been this long-term commitment to support financially the CDSE, so that there is a trust in continuing using the solution and even developing further on top. Developing further on top is also essential. User-centric communities, the building of communities to provide further services, data, and support to specific communities. And this we see that on the CDSE, there is a real willingness to support those communities. A lot of communities are uneased in using satellite data. And what matters is that there is the provision of easy-to-use tools to start and to progressively help them using those. And we see this, that there are new communities coming in, but of course they need to have the tools, the interaction, the user forum is there. There is really a need to further interact with the circle, which is further downstream than the Earth observation users. Now, also, there is the ecosystem, and Simonetta has been talking about a lot of things, and in particular about this ecosystem where the different companies providing Earth observation services can do that on top of such an infrastructure and such on the different layers of the CDSE, and to further provide value-added services to their user. The third thing is challenges. We know where we are, we know what is the state of the environment, and with the tools like Copernicus as a whole and the Sentinel's data as well, we know more and more, and we get a better knowledge of the environment parameters and where also we are going if we're looking at a service like climate change. So the challenge ahead are huge, very important. So this is the importance of the Copernicus program and the importance of the CDSE to be able to provide such information to the different user. And with this, thank you very much for all being here.
We have heard a lot about new data sets already, but I would like to go a bit through the details and to put this in a conceptual framework so that you understand where we are going and where we started from. Well, this is the very first motivation for Copernicus Data Space Ecosystem that we like to quote from Thierry Breton, the Commissioner for Internal Market. So we want Copernicus data to be easily accessible and usable. And of course, we want a data analytics environment, but the first stage is really to make the data accessible. And to many users, the data set itself can often be a problem. So however accessible we make a Sentinel-2 or a Sentinel-1 image to a farmer, it's still not going to be accessible to them because it's still just going to be a satellite image. And so we are rethinking a bit how to go one more step closer, how to approach our users by providing data in the form that is really accessible to them without having to step out of their role. You don't have to become a data scientist or become an Earth observation scientist in order to make use of these data sets. You can just do your thing and we will serve the data for you in the way that you can actually use. So I get a lot of feedback because I talk a lot to users. And what we keep hearing is Sentinel data is cool, but, and the but adds up to, and you've seen from the feedback from the user survey, right? We want higher spatial or higher temporal resolution. What do we do with 5-day, 10-meter data? We want to avoid data cleaning and preparation. We want this to be done for us. We don't want to deal with that. And we are not Earth observation experts, so we want the end product and not the ingredients. We want the bread and not the flour and the yeast. And very often we have a good solution that stumbles on the nature of the data. It's not brought close enough to the users. This used to be a super popular custom script in the early days, actually, of the platform. It's called Agricultural Growth Stage. So what it does, it takes 3 months of satellite images and it assigns the mean NDVI of the first month to the red channel, the second month to the green channel, and the third month to the blue channel. Actually, it highlights differences between crop fields. So it's really, really useful for vegetation classification and also understanding vegetation patterns. But because Sentinel data arrives in swaths and because it's processed in tiles to cloud coverage, and we filter according to cloud coverage, the result you get is often messy. It's not ready to use immediately because of the nature of the raw data. And so what you do is you create an analysis ready data set like a mosaic, and I'm going to tell you more about this mosaic, and apply the very same algorithm. And now it becomes clean. And now you don't have to understand that this has diagonal swaths or whatever. The data is just there, and you can look at the differences between fields. So this is sort of the solution we are trying to go towards. And of course, the keyword here is analysis ready data. And analysis ready data is, of course, a big topic. There's many different ways to make data analysis ready. So just for the sake of this presentation, I will try to conceptualize this and try to address these levels, which are used in many different ways throughout the EO community. So I will say level 2 is like a level 2 Sentinel image. So it's radiometrically corrected, it's atmospherically corrected, it's geometrically corrected, it's gridded. So most of the noise is filtered out, and you can use the data in the image bands. And then level 3, the next level beyond that, which was originally not in CDSE, but is now available for many data sets, is a seamless mosaic where you don't have to worry about the edges of the image. It's also noise reduced, like the main sources of noise, slope for Sentinel-1 and clouds for Sentinel-2 are filtered out. It has a constant temporal resolution. So it's not either you get an image or not, but it's really with a specific cadence. But it still retains all the image bands. It's not a biophysical quantity, it's an image. And then level 4 is something that's directly related to a physical quantity, ideally calibrated to actual measurements of that quantity. And it has a known accuracy relevant to the biophysical quantity. So we know the signal to noise ratio of a Sentinel to image, but of course, and we know, how this propagates to NDVI. But if we want to calibrate this to vegetation biomass, we have to add an additional layer of correction. And this is what level 4 is about. And of course, we keep talking about machine learning and AI. And for those who haven't done or experimented with this before, a very large portion of the task is the data preparation. You can have a very good model, you can have a very good network, you can use a nice large language model, but getting the data in the format that it's ready for the AI to run on, that's a very, very big part of the work. And so level 3 and level 4 AI are much better suited to machine learning or AI processing than level 2. So this is why we are sort of moving in this direction. Let me give you some examples. So Sentinel-1 is somehow the ugly duckling of Copernicus, because the data is not that pretty, right? It doesn't have a true color. It's difficult. It has speckle. It's difficult to engage with immediately, right? And so actually preparing monthly Sentinel-1 mosaics is really a game changer. You see, if I go back, so this is a place in Austria, we have very prominent slope effects. And these are really nicely evened out by this local resolution weighing that we do. It's a monthly mosaic, so it's a weighted average of all the polarimetric products in a month. It also has radiometric terrain correction applied. And this means the visual interpretation is much easier as well. So it's easier for newcomer users to understand what's actually happening with the radar image. And since it's regularly produced once a month, and it's of course cloud-free and seamless, this is really a nice data set for AI-based processing because it's it's a level 3 ARD. And again, the same applies for Sentinel-3 quarterly cloudless mosaics. We often use these as a baseline. So something happens somewhere in the world, and you can have an image of the current situation, but if you want to go back to what was there before, and you need it to be seamless and clean and cloud-free, you're probably rather well off using the quarterly cloudless mosaics. Again, this has a very simple process behind it. Of course, we use level 2 imagery, so it's slope corrected, it's labeled for cloudiness. We throw away the cloudy pixels, and then instead of taking the average, we take the first quartile. And that's just because if there is still a cloudy pixel in there, it's going to heavily influence the average, but it's not really influencing the first quartile. So the data is really, really nicely clean. And this is seamless across the whole globe. So if you just pull up the CDSE website, we now have a rotating globe visualization of this, and it's super popular because it's very easy again to engage with. And the mosaic you see here, I mean, running all the way from from central Sweden to the Sahara in one image, in one go, makes it very popular for teaching. Again, you can see global scale processes on this. And of course, it's analyzes ready data again. What you see here is a data fusion script. So the blue part is a flood delineated using a current Sentinel-1 image. And the true color part is the Sentinel-2 quarterly mosaic as a backdrop. So showing you what is where and how the flood relates to the things on the ground, right? So this way you can combine the ARD with the instant data and create information that's actually useful for a first responder or an insurance company. So this is how it works. People keep nagging us for higher spatial resolution. And now that we have Copernicus contributing missions data available, and not just for download, but the 2018 and 2021 mosaic also available for visualization, you have for all of Europe at least a benchmark or a couple of years of a benchmark for high resolution. And again, this enables you to use visual interpretation and add an analysis layer on top. You can find your house, your place of interest, using the high resolution data, and then maybe you can pull in a thermal image or a current Sentinel-2 image to see what happened with it, combining one layer with the other. It's not accessible to every user, but it's there and it's available. And then talking about level 4 ARD, biophysical quantities, Sentinel-3 level 2 data is really changing the game here because this is daily data. It has relevant biophysical parameters over land for vegetation. It also has very good calibrated ocean color products over water. And at the daily repetition rate in 300 meters, this is really data that users can instantly relate to. Now we dive a bit into n-dimensional space because we are all data scientists here, right? So what do you see on this graph? On one axis, you've got ARD level from 1 raw imagery to, I need the pointer, to 5, which is highly processed data. So from here to there, the data gets more processed. Then from here to there, the data gets more frequent. So 1,000 days is like several years, of course, 3 years, down to 100th of a day, so maybe an hour or two. And then the third axis is spatial resolution in meters, going from low resolution, so kilometers, to high resolution sub-meter. And then our favorite workhorse satellites, Sentinel-1, 2, and 3 are over here with 2 to 5 daily data, 10-meter resolution, daily data, 300-meter resolution, level 1 or level 2 ARD. And Sentinel-5P is over here because that's actually producing calibrated values of air pollution as a default, right? Low spatial resolution, but at high ARD levels. So this is the basic menu. And now what are we adding to this? We are adding Sentinel-1 and Sentinel-2 monthly mosaics. So these are only processed with lower temporal resolution, once every 3 months or once every month. The spatial resolution is the same, and the ARD level is moving in this direction, right? It's easier to work with. We are sort of filling the gaps in this space. And then, moving on, we have the CCM VHR data over here, right? So this is still level 2 ARD, but the spatial resolution is going in the direction of meters, but it's also down on this axis because the revisit time, it's only processed every couple of years, right? But still, again, we are moving away from our original data sets and providing new ways to work with the data. And just to show it very quickly, commercial VHR imagery is up here. High resolution, high temporal resolution, very low ARD levels. We're not really offering this in CDSE or only in the CrowdES EO Data Plus store. This is a different part of this landscape. But Copernicus land monitoring service data are moving closer towards the users. So this is ARD level 3 and ARD level 4. Some of the data sets are updated daily, but what I'm showing here is the annually updated data sets, phenology, land cover. And then if we add to this all the data sets on snow, soil moisture, and hourly temperature is way up here in terms of revisit time, right? This is sub-daily data. So we are sort of filling up this landscape and providing more and more different offers to our users. And then just to put everything on the map with the Sentinel-2 mosaics and the CLMS data and Sentinel-5P and CCM VHR, you can see that really from one sort of small cluster, we are growing out towards a very large cluster and hoping that every user finds what they need. So just to run you quickly through Copernicus land monitoring services, This is one of the Copernicus services. It's run by JRC and EEA. They are coordinating the processing. These are actual calibrated downstream data sets relevant to land management and management of inland waters. And these are rigorously calibrated to physical data sets. Their accuracy is relatively well understood. So we have land cover here at 100-meter resolution in yearly time steps. It's regularly updated every year, and it has a global scheme of categories. We have soil moisture data, and our farmers have really been asking for this for a while. And this goes down to 1 kilometer resolution daily soil water index data. That's the finest resolution that we get. We have snow properties, and this also includes snow water equivalent based on NPP all the way from 2017 to now. And this is again daily data, daily global data. We have surface temperature data, 5 kilometer resolution from geostationary satellites, but in hourly cadence. And you can watch this on the browser, but you can also access the individual files by time of acquisition. We have vegetation properties, and this includes what you see here is productivity, but this includes NDVI, F-cover, burnt area, phenology, drag, and gross matter productivity. So again, data sets relevant for agriculture. And we have lake water quality and lake monitoring, water bodies extent. So all in all, what you see here is that CDSE is on the move. We are moving from producing only raw data that you have to build on to actually producing up to level 4 analysis ready data and products that our customers can build their systems on. It's possible to integrate the data from CLMS directly into a farm management system. You could even put it up on the tractor with a WMS on a tablet. So this way, I think we are really trying to answer our user needs to come closer to them, because what they are asking for is the actual result, the actual data set, and now it's here. Thank you.
Thank you very much, András. I think we have time for one question before we go to the next presentation. Question in the audience.
Yeah, just a question. First of all, I think you make it a little bit simplistic that everybody wants a mosaic. That's not true. So
that's not true.
The point is that you apparently go, this is Sentinel-1 specific, you go from level 1 to level 4 or whatever it is in your thing, and you forget to store level 2. And that's a general problem on CDSE, is that there is no level 2
for Sentinel-1.
For Sentinel-1, yes. So, and if you are making these mosaics, that means you have to go through that level 2 processing before you make your mosaic. VITO makes crop maps, also has to go through level 2, and then does a crop map, right? Vienna does level 2 processing to derive soil moisture, and only publishes the soil moisture and throws away level 2. So what happens to this level 2? The people, I mean, the user would like to, first of all, have the level 2, and then they can decide whether they do other things that are maybe not available yet. But the main problem at the moment is that, and this is now for 10 years, that there is no level 2 data available. The tools that you have for that are open source and standard, can be accelerated, whatever, but there's no place other than, you know, the elephant that we don't mention, where this data is stored. So, and that I think is something that needs to be addressed first before you start to say everybody wants to have a level 4 mosaic, because that is definitely not true. Because the other thing that you should realize, that if you make your mosaic, you throw away a lot of information. If you have a monthly mosaic of Sentinel-1, for me, there's zero information in that I can use in practice. So, you know, it's not so simple.
Thank you. And first of all, I want to say that we are really hearing your feedback, and we are putting it in place when we are thinking about further development. It makes sense what you are saying, and if there's demand for that, then we will keep it in mind. But I may have formulated somehow inaccurately, because I said we are moving from level 1 to level 4. We're not throwing away level 1. We're still serving level 1 data. We're still serving individual data to everybody who wants to use it. It's absolutely a part of our selection. We are adding further analysis ready data sets on top. And with level 2 Sentinel-1, I'm not a big expert of Sentinel-1, but I have the feeling that your question sort of answers itself, because different parties are processing Sentinel-1 level 2 in different ways. And that's the problem. It's even, we are already struggling in a bit with Sentinel-2 level 2 data because some people are saying our level 2 is not good enough. They want to create their own. So if there would be a very clear standard way of how to generate level 2 Sentinel-1 data, I think that would be relatively easy to serve.
Yes, new platform. It's called S1GRD on Google Earth Engine. It's exactly the same stuff. So, I mean, this stuff has been, I mean, the fact that it has been processed for 10 years with the same recipe, that is a snap recipe, means that there is, okay, of course you can decide to tweak or make not the gamma 1 or sigma 1, but that's all, you know, simple detail. That's not a problem. But the real issue, I mean, these things are actually convertible between one and the other. The point is that indeed you keep level 1 and you make level 4, but you throw away level 2. That's what my argument is. If you do this mosaic processing, make sure that the level 2 that you processed in between is available. And then for me, we can probably throw away some of the level 1 data that we don't need. And in that case, for instance, GRD, because that can eventually be regenerated from SLC. Okay, well, that's technical, but so there is a clear need for this. It is simple, it is standard, it is done thousands of times. It's done exactly the same by all these different parties that push out their product but throw away the intermediate. So there's endless repetition of this. And if we solve it once, it is solved. And the thing is, we have a proven case for this because it's been done like this for the last 10 years on Google Earth Engine. And there are thousands of users there that use Sentinel-1 level 2 in their applications, whether it's forest, ice, whatever. By the way, you also have to do radiometric terrain flattening, but okay, that's a side issue. But doing it. But no, so I don't know why this cannot be solved. I was in the Sentinel-1C session before. I've asked ESA to start addressing this because it's not, I cannot really understand why 10 years after Sentinel-1A, we have still not solved this problem. And everybody says, my standard is not your standard, whatever. That's nonsense. I mean, somebody has decided to generate level 2A at some point. There are then always people that say, oh, I can do it much better because I have this or that tweak. I mean, that's irrelevant. I mean, unless that is proven to be so much better, then you would have to switch. But for Sentinel-1, there is no issue on this at all.
Thank you. I see several people raising their hands in the room. So before I try to answer, I would actually, if other people want to address this question or have feedback related to that, please go ahead. Yeah. Can we start with you,
related to that? From an ESA perspective, I will say.
She was firstly, so I would let her.
Yeah, sure.
We probably have a similar comment anyway on this. So maybe to answer on Guido's comment, I think you are completely right. This kind of data is missing, is dramatically missing on Sentinel-1 family since very long time. One of the reasons is probably as for the Sentinel-2 happened for the level 2 for a long time, there was no agreement on the way forward. And this has been blocking things for a long time. So we have now put in place a processor will be an open source to generate this. And the idea is to have a new Sentinel-1 ARD product that will be available systematically. That's something to be agreed anyway with the Commission on the implementation of this. I would say they put in operations, but that will be ready for operations next year. There will be one remaining question to that, and I think that's probably a very good topic to discuss, is whether this kind of product is a replacement to the JRD or is on top of the JRD. I think this is a question that on our side for the time being is open. I have my personal opinion on that sense. I think it could completely replace the JRD. I know that's not necessarily everybody's opinion in that respect, so that could be a debate in that sense. But what we are putting in place is a Sentinel-1 ARD, which is totally synergetic with the Sentinel-2 level 1, level 2 products that are available today in terms of access, in terms of geometry, in terms of combination. So.
Thank you. Would you like to add something?
Yes, sure, please. Yeah, I'm the original developer of the radiometric terrain flattening and of the level 3 local resolution weighting.
Wow.
And so I just wanted to say that it's great to see this all coming through, but But just to respond to this point that was raised of there being a plethora of different methods that people are applying, in reality, we've really codified this into the COCRD process, and you can just read these product family specification documents, and things are modeled there quite well. And there really isn't a lot of controversy on a lot of these points. So I think one can overplay that point that there are nuances, yes, but there's not a huge diversity, really. Yeah.
Okay, thank you. I think this really draws the way forward for us. I really hope that we can move on with Sentinel-1 Level 2 data in the future. Thanks.
Good afternoon, everyone. Nice to see so many people interested in CDSE and CLMS onboarding. Actually, listening to the previous discussion, I'm regretting not having put up a completely other topic, because I have in COS developed some ideas around processing levels. And this stuff is really hot, so we surely will have to have a discussion, but that's maybe afterwards. For now, today I will tell a little bit about our journey as the land monitoring service to onboard on the CDSE, which is an endeavor we undertook in a bit less than a year overall. And so this does not work, but maybe this does, yes. And we actually started thinking about what we then called cloudification a long time ago. The Copernicus Land Monitoring Service is one of the first services that had been established in Copernicus, so there is quite a history of production, and it came out of the pre-cloud era. So we had relatively traditional concepts. We had a relatively clear differentiation between what we call the European and the global component. And everything was kind of a bit patched together. The products existed in different places before. That's why it was all very decentralized, and it was, just basically tried to be put together. We built a GUI on top to somehow have a portal for the users, and it was not really. I mean, after a couple of years, it was becoming clear that there is much more that you could do, and especially with the advent of the cloud platforms, we of course saw the need to look into that as an option. In around 4 years ago, we undertook this study how to cloudify the service and looked into different technologies. Of course, the report was relatively quickly coming to the conclusion that there is a lot to improve in the land monitoring service, the inhomogeneities, inconsistencies that came out of this kind of decentralized organic development in domain names, user databases, web presentation, no consistent API, no single data catalog, limited interoperability. You see all the points on this slide. So there was simply obviously a need to kind of pimp that up, and so what we were basically learning from it, that moving to a cloud platform should be the way to go. It would give us better scalability, and of course we were also at that point recognizing that the old system was coming to its limits, because the data that were coming with the increase in resolution would be many times what we had. So there was clearly a push for better integration, also with downstream processing, and at that point we pretty much said yes, we want to go that step. And that was at more or less the same time at which we had this occasion, because of course everything in the services is operational. It's running on contracts that go for many years. You cannot just change anything from one year to the next. So in beginning of last year, we saw the chance to do that move, and that was more or less the same time where the CDSE has just come out of its first baby phases and teething problems, and was clearly presenting itself as an option. So we got in touch and we said we want to do that. We want to basically put all our eggs into this basket. And we started with these global data sets that at this point in time were the ones that were the first ones that had to get a new home. And of course, we saw a lot of advantages, and I'm not going to read them all on this slide. There were many things offered there which we could not do and which we probably couldn't have never established easily independently on just a portal. So it was clearly the best way to go. But one of the primary arguments for us was that this would be the home for all the Copernicus data sets, and we don't want to see our service data just to be treated within itself. But we are sure that there is a lot of added value if you bring those together with the Sentinel data on one hand side, from which they also largely originate, but of course with all the other services data and the possibility for the users to interact. So that's interesting. Oh, you're not seeing any slide here. Okay, so I've not only lost the control with this thing, obviously I'm sorry.
Can we try to use the remote?
They can flip in the back for you.
No, it's working. It's
okay, so this was the one I was speaking to.
This is the one that is showing.
Okay, now it's getting. Can you forward the slides if I tell you? Because this was the one. Yes, that was the one I was just speaking to. So the integration with Copernicus. If you now go to the next, we try to stay in sync. Yes, good. Okay, I will actually have a look there. Then I can see what's. No, it's okay. I can easily see it. It's fine. So it was of course much easier said than done, because I think we were the first service that was really trying to do this full onboarding and integration. And the CDSE at that time was pretty much built around the Sentinels and as a ground segment platform. And of course, what we do in the services, and we just talked about processing levels, and that this stuff is considerably different in many ways. So it was clear that we would see some challenges there. But beyond that, of course, we had to also kind of do a lot of homework on our own stuff. We talked about all these inconsistencies, inhomogeneities. If you move everything to one platform, it all surfaces. You suddenly find that your products, your metadata structures, everything might have little tweaks and inconsistencies, and everything. If you put it all together, everything starts showing. And that's the point at which you have to clean up and harmonize and make sure that everything is nicely fitting together. And that was a serious piece of work. And here are a few figures about the short time actually in which ultimately we managed to do this. And it was a real intense time. So we tried to get all these people together, and we moved roughly half a petabyte of data. And this is really the least thing is the copying. The primary thing is really the cleaning up, the structuring, the documentation. You see the number of 3 million individual products. Of course, the idea is that nothing. Sorry, I was forgetting to. You should have forwarded. Yeah, the idea is of course that nothing should be lost. So that was the point at which it was really getting important that we had a very operational setup and a very good and intense cooperation with all the different parts, which worked quite well. So where we are now, next slide, please.
Click it yourself. You push on the green button, then that one works. Yeah.
Does it work now?
Yeah.
And now it works again. No, not backwards. Backwards. Okay, I'm in control again, right?
Yes.
Let's see. Okay, so where we are now, you saw some of this already this morning. I won't spend much time on this. The data are in the browser. Many of our of the former global data are fully integrated. They are basically now accessible, and the new stuff is now directly coming to the CDSE. Of course, it was also important to make sure that it works. It doesn't work here. Okay, never mind. So there is still a few things to be done. I mean, one that you see here is this land cover forest monitoring. That's a milestone because that's the global 10-meter data that is happening while we speak, because this will be officially inaugurated at the conference here. There is other smaller parts coming, like the high resolution snow and ice, and we are going to see all this in the relatively near future. openEO is coming, Stack is not yet there, but will be coming, I think, all pretty much in the next few months. So it will definitely be something that is worth watching. But it's in the end not just the data. It's not just to basically park the portfolio there. What we also wanted to do, and that's kind of a sidetrack that we did at the JRC. We wanted to see whether we can basically do things that before we only could do on the very big elephants, whether we could also try to port some of this over to CDSE, and that's what we did with the Global Surface Water Explorer. Some of you might be familiar. It's a quite famous product in the surface water world. And we basically said we want to see how that works in the CDSE. So we migrated a large part of the Landsat collection data, also for the reason, of course, that we think it's a good idea to have a copy of that in Europe. We started to see that we can implement the process there, and we did some real large scale number crunching, and we are pretty happy that this worked, and that this basically given us the security that we can do this kind of petabyte scale number crunching also in reasonable times and with reasonable performance on the CDSE. So what you do after a project, you do a bit of debriefing. What worked? It's, I think, what can be underrated is the great team and great spirit. It was really a very, very good experience overall to work together to get this accomplished. We found a suitable and solid infrastructure, state-of-the-art services, not too much to complain about. That's really all fine. The tech support, I think, it has really ramped up. Also very worthwhile mentioning is that the user forum is becoming more and more active. That's a very important component of a living platform. And of course, the pragmatism to really overcome anything that can go wrong. And of course, everything all the time can go wrong. So what needs improvement? Of course, the things that go wrong. But as I said, it's still happening, but usually it's being taken care of in reasonable time. Of course, it will be even better if it doesn't happen at all. So that's something I think that's with the usual teething will get better. And as I initially said, we have to kind of shape CDSE more towards a home for this, what we call higher level products. I'm very happy actually to have seen this presentation before. It's something that very much resonates with us and that needs some changes to data structure and architecture. So we need to basically think about how in Copernicus we organize our portfolio, because when you put things together on one platform, any inconsistency will show. So for our users to give a good impression, a good way of working with our data means that we also have to make sure that we have a good product architecture behind. Then the big topic of the metadata and how to basically harmonize and make sure that all these different, and there is of course a lot of different standards out there. Stack is kind of the cool kid on the block, but Stack is not one standard. Stack is a collection of many items that organically grew, in which there is some things that need improvement before I would actually really subscribe to it as a standard. So I would say it's not yet ready. What we have to, I think the most important thing now for CDSE from our perspective is to really kind of make sure that it becomes that integrated ecosystem that it promises to be. That's something that also the speaker after myself will, I think, highlight very nicely. My last two remarks here are community. That's something we need to work on more. I would see next time this room has to be full with people standing in the corridor. And that can be achieved. We had some experience with a hackathon earlier this year, which I think was extremely good. We have to do this every 3 months, every 4 months on different topics in different application areas, different audiences, the boot camps, the sprints. That's the kind of stuff that attracts the community that we need on CDSE. So that is certainly something to be massively ramped up. And then interoperability, that starts with COSARD, with processing levels, with architectures, with metadata. And with that, I finished. That's an area very close to my heart. I work a lot on this standardization. I really hope we can take the CDSE along. So you can call it flying. And of course, we thank everyone who contributed to that. Thanks.
Thank you. Good afternoon. My name is Matteo Mattiuzzi. I'm working for the European Environment Agency in Copenhagen. And there I'm working for the CLMS, so Copernicus Land Monitoring Service team. And together with JRC implementing the global component, we are implementing pan-European products. Now I will see if I can, I see there's a difference indeed. Don't use the laptop. Yeah. Don't use the laptop, yeah. And press on the green button. Yes. And going back is the red, I guess. Yes. Okay, good. So my presentation will be about our experience or our situation, our status in the migration of our CLMS products. And as a keynote, I also would like Peter actually, to give some messages ahead. So what we think is important, Copernicus should develop to. First, about the status, we have heard the global products almost being all migrated to the CDSE. We are starting now with our EA products. The first one is the high-resolution snow and ice, which is a discontinued, so a closed project, is replaced by the high-resolution water snow and ice. The snow and ice product is migrated as an archived product, which means it's there for legacy purposes, but it will not be accessible through all the services that the CDSE is offering. Because in September, we will have the high-resolution water snow and ice product, and as the name tells, it adds more focus on the inland or freshwater monitoring in Europe, and it will be fully integrated with all the services that CDSE offers. And this will happen by September. For users, this means very nice products on snow cover duration, water cover duration, ice cover duration in Europe, near real-time information on water, snow and ice, or also the status of snow, wet snow, all in high resolution. And once this is done, we will be focusing on the migration of the remaining products, so coming maybe, hopefully, to an end of the entire CLMS portfolio by the end of the year and maybe a little bit beyond. Now, what does it mean for the CDSE and its users to be migrated on the CDSE? We have obviously an important amount of pros, so advantages, and based on this, we took the decision to do the migration. And surely we can say the proximity to Sentinel data. Sentinel data is the main or almost unique source of our product, CLMS product, Sentinel-1, Sentinel-2, and including the global component, there is also a high degree of Sentinel-3 data. This is important or good for our production workflows. So data is on-premise, the processing is on-premise, and the publication is on-premise. So we expect advantages in that regard, but also for our users. So far being CDSE users, so far being able to work with Sentinel data, now they will also be able to combine the same way also CLMS products and vice versa, obviously. Then with the onboarding, we are joining state-of-the-art data services and productivity environment. These days, with the large volumes of data, providing data is just one out of at least three essential things. So we need the data, we need the processing resources, and we need the tools to handle 1,000 to 1 million files or terabytes of files in the processing. And offering only one is just not enough. Then, of course, the processing resources at scale on-premise where the data is. And then also the low-level connectivity to VITO. Our data will continue to be accessible on VITO, which is the place where other services, Copernicus services, are also publishing their data, and where we are cooperating on these services. The risk in joining the CDSE for us was that we risk to lose the CLMS service specificities. So this is what maybe also Peter mentioned. So the CDSE had to grow from a EO data platform, and actually has still to grow from an EO-centric platform to also provide EO-derived products, or the higher level products. This obviously came with some effort, some pain. I think we are still not there, but this is, I think, a natural progress, and we are progressing quite well, I would say. Now, if we are considering the bigger picture, as I said, users have access now, direct and efficient access to Sentinel data. Now they will have efficient access also to CLMS data. But what about the other data, about the other services? How can they are currently not really streamlined or well federated into the CDSE, or each other federated? So a user to work with, for instance, Sentinel data and CAMS data, just to mention one, might have to work on two different platforms, two different accounts, two different workflows, which is definitely not the way we should offer our data. And I am convinced that more centralization is not the right direction. We need to work on more cooperation and more alignment. And the point is, we must function as one while being many, because we are different services with our specialties. We know our data, and this influences how the data needs to be accessed, how the users, specific user expect to access our data. And this is also how we are interacting with our users, or our users are interacting with us. I think we should always focus on the user needs, and of course this can be simplified quite heavily. As a user, I would expect that I don't have any boundaries in the data pool. I want to access all the Copernicus data and beyond within one data pool. That should be our goal. It should not be that we have to register somewhere else and implement different workflows to access other data, and then eventually also to combine this data. And data pool comes always with also processing and productivity facilities. As I said, nobody can handle 1 million files or 100,000 files. We need tools to interact with this data. So a user expects to access this data pool, having scalable resources where the data resides. Then this environment requires to have a low complexity. So it needs to be simple for users to join or to work with this environment. In 2023, we made a survey where we asked our users, why are you not working on the cloud? And one of the most frequent answers was, it takes a huge investment to migrate my workflow to the cloud. Investment in human resources and also in adapting the workflows that are established somewhere else. And we need to bring this difficulty down as much as possible. Then high capabilities, and here I mean that so when I migrate my workflows to the cloud, we should impose the least change to our users. So ideally, they can take the workflows as they have it and implement them as easy as possible also on the CDSE. And here I'm also thinking about the programming language that users are using for processing their data. And high performance, when we are talking about a distributed system, obviously the bottlenecks that are data traffic, so egress, ingress from in between the infrastructure, which is always a bottleneck. We need to put a lot of energy to mitigate this issue. So methods to reduce, to keep high performance while being on a distributed system. I think it's also important a single billing instance. So even if I'm eventually in the background working with different clouds, it would be good if I don't have to interact with different billing instances so that I get one invoice for all my processing while being happening in different places. Trusted Copernicus user account with my Copernicus account to be able to access all the data, all the Copernicus data, and not only the service-specific data. And then as a user, I might also want to engage with the specific services or with a specialist who does know better CLMS data than the entrusted entities implementing this data. And same goes for all the other Copernicus services and entrusted entities. This user needs reflect also to responsibilities that we have as a service. And here I am very convinced also again in this distributed setup, open and deep federation, implementing deep and open federation standards across Copernicus. I say deep because often federation, when I hear the word federation, there are different levels of federation. So it can be a very shallow federation and it's used as name federation, but federation goes, it's my life. Federation can go very deeply and can be quite an effort to implement. So this federation goes in coordination across Copernicus, the implementation of metadata, of catalogs, then to agree and implement cloud-friendly data formats, to implement shared data services, to minimize the cloud traffic. And I think here about a smart data caching and distribution framework, which I think does not really exist. Obviously support on-premise distributed processing. So wherever the data might be, there needs to be a kind of processing node where user can process from remotely. I'm thinking at frameworks like openEO, for instance, or maybe there are others. And then avoid any vendor lock-in for software and hardware. For software, this means to me implementing on open source, state-of-the-art tools. I think there are good solutions outside. This software needs to be easy to clone to other locations to join, for instance, this federation framework. And hardware, and here I'm thinking about the cloud infrastructure behind. I think we need to find a system where we can keep that competitive as or allow competitors to easily enter into this federation and offer the services. Thank you. Yeah.
Good. So openEO and what it tries to do. So what is the question that everybody probably has, and we as well, is how to have impact with Earth observation. And my answer is relatively simple, and you also hear it elsewhere. If you just get it integrated everywhere into society, and often maybe in the background of larger applications. So not necessarily as looking at pictures, looking at maps, but really more integrated into business processes, into intelligent algorithms that provide some kind of value. That's easy enough, but how to get there, right? So yeah, what do we need? Well, the thing is that, and I've taken here the example of a project I'm working on related to glacier monitoring and the water it takes. It's not only about developing the algorithm and doing the calibration. You also then need to turn your algorithm into an actual Earth observation service. Then you need to be able to sell it.
and then it needs to run in operations. That's also a theme that you hear throughout the conference. Your information also needs to be very timely. Information loses its value quickly as time goes on. Historic information can be relevant for certain purposes, but very often you need it to be timely. You want your algorithms to be easy to integrate, and not just for EO experts, but for any IT integrator that doesn't know anything about EO. They also should be able to just pick a few algorithms and integrate them in the tools they are building for their customers. Often different use cases need specific parameters. So static maps is not always what you want. Sometimes you want some on-demand parameters that the user can tune. Then, of course, the business offerings need to be clear. There's a whole business side to it. And for the operational people, it definitely needs to be reliable. It just needs to work, not be too complex necessarily, but just work. So what is our small contribution that we try to make with openEO to this much larger problem? We try to make it easier to go from an algorithm into a service that is really fair compliant. And then we really mean a web service that is offered in a reliable manner. So even backed by the SLA, for instance, that CDSE has anyway. We want to accelerate this a bit thanks to this very generous public service, allowing users at no cost to do this service setup, this algorithm integration, and also for end users to use the resulting service. The standardization, of course, is a key point for openEO. We try to avoid the vendor lock-in. We offer toolings and features around it to facilitate this operational integration, for instance, also to build large area maps. And then finally, for the business offering, we also try to make services comparable. That's also a nice side effect of a little bit of standardization and offering it on the same platform, maybe even with a shared credit mechanism, that it becomes much easier to compare what a service really is and what it really offers. Sometimes if it's hidden in different APIs, then it's harder to compare. That's something we're also doing in the ESA Apex project, for instance. And then maybe good to mention there is that we're also building this federation. This was something that we now, I think, already released a year ago, but we also wanted to repeat the message that we're also open to adding other backends into the CDSE openEO Federation, where we want more providers to join. And a big message yesterday was also that we now have the Copernicus browser also that will be exposing an openEO API. So that's the next logical member, so to speak, of our federation, so that as a user of the current openEO, you will also easily get access to Sentinel Hub based openEO, which has the very nice advantage that you get quite fast response times. The processing set is more limited, but you can get results very fast. Good. So then I wanted to also show some nice cases. This one was shown before noon, but so it was explained quite well in detail. And it's the ESA World Serial System, which allows users to generate crop type maps, but really on demand. So let's see if my video starts. Yep. So this is all running on openEO. The user can find it in a catalog next to a bunch of other services. Then he drops into the World Serial user interface, and then just using this interface launches the processing. And then I think we go a little bit behind the scenes once we are done selecting our area. And then you will see that it actually switches, or we show the openEO UI, where actually a job is launched in the background. And the key thing about the system is that it's now available to all users worldwide. So they just get a CDSE account and can use it using the public service. But also for the World Serial project itself, there is no operational cost in keeping all of that up and running because they built it inside openEO. So it's really in the first phase of the project. Afterwards, they actually had to shut down their components because there was no budget left. But if you build it on top of this operational service, then there is no more operational cost. So that's a big advantage to the World Serial project. Another one then that's more like on the opposite side. So inside the Jupyter Notebook, more like a scientific, how a data scientist would work. And this is our heatwave example. This year in openEO, we managed to integrate basically, I think, all of the Sentinel-3 datasets. So now it's really easy to get access to also this very nice data throughout openEO. And this one is an example of heatwave mapping. You really see that in the processing that was done here, a lot of products went in there, and I was able to process most of Europe. And I think the image is like the number of heatwave days that are shown. I think the cost here was about 50 credits, whereas what a user gets in CDSE is 10,000 credits per month. So yeah, that's pretty low. So let's look a bit more at some numbers. This is our processing volume, and you see there we really have nice growth. The bump in these last 3 months, the last month is incomplete, but the 3 months before, that was thanks to some major projects also doing their work on openEO. So that's continental and global scale processing going on, really causing also a nice increase in processing volumes. Then I also did a bit of an analysis of the cost distribution, let's say. And in this graph, I normalized the cost for jobs, I think, of the last 3 months. And then you could really notice that, basically 75% of jobs that average users run really are quite cheap. It's only like 10% where you see that cost is somewhat elevated, and we need to work on that clearly. But overall, our target of being a low-cost system seems to work quite well. So then, roadmap-wise, what you can expect. Performance and stability has always been, but it remains a major attention point. I think that's really what users are asking for. But also the development experience. So that's a comment we do get. It's like, it's a web API, so you need to submit a job, wait for results. And that's like makes your iteration time longer compared to just running things on your laptop. And that, for instance, the Sentinel Hub offering with the openEO API really helps also to speed up this iteration cycle. Then, of course, more data sets is always on the horizon. The CLMS ones are clearly a nice example there. Facilitating ML model integration, that's also a nice one. In World Serial, they still had to do a lot of manual work. So we noticed like what is needed for a project to do this, it should be a bit less. So that's a clear, nice feature that we can add. And then other things like metadata export, the ZAR support, like the write support is almost done. That will be quite nice for people to play with. And then, stack 1.1, large scale jobs. So really very many small features that we are adding. And I think that's it. So thank you, and I may have some time for questions or not.
It's a user review meeting, so we can allow a question. Yes, indeed. Anyone? Yeah, we have. Can somebody bring a microphone? Yeah.
Thanks, Jeroen, for the very nice and clear presentation. I have a question about the ML and integration. Can you just give a few examples of what you plan to do there? And then another one is on agents and things and next steps there. Do you have any plans there or any ideas? Thanks.
Yeah, thanks for the question. On the ML integration, the ONNX format is very nice. Because that is, it's a standardized format. And the problem used to be that you had all these different libraries like Torch, TensorFlow, and so on. And ONNX standardizes that. So that fits very well with the standardization approach of openEO. We can come up with a process called run ONNX model that you then just use as any other process. So that's one way. Another interesting thing is also the support for foundation models and embeddings, which a lot of platforms are doing, that you have pre-computed embeddings that you offer that maybe you can do an openEO load collection call and just load them. That's more like a piece of research that we do have also a little bit on our planning. Of course, doesn't mean that we immediately get it into an operational setup like CDSE. That will take more time, but for sure something we want to look at. And then on agents, I had a small demo yesterday in our Agora session where, it's very similar to something Google announced a couple of weeks ago, where you use a regular chatbot to not ask it to produce the map itself or complex Python code that produces the map, but to produce an openEO process graph. And that works quite nicely because the openEO specification is also formal. So the language models seem to work very well with that. As long as you give them the reference to the spec that they should keep themselves to. And the nice advantage is then as a user, you can look at what it generated, inspect the workflow, which is openEO workflows tend to be relatively short, or at least shorter than Python code blobs. So it's easy to detect if it hallucinated something, if there are bugs. And then you can just run the workflow to do your analysis and really trust also the result. It's very similar to something Google has been doing. But that's more like in the ID kind of phase still.
One last question then.
Thanks for the presentation and for the update on openEO. I see that now there are a lot of projects really using openEO operationally and producing real value data sets. And I wanted to know how many like user-defined functions are usually included in these real world, like top-notch science experiments, because openEO has a set of predefined functions or predefined processes. But sometimes I have the feeling that maybe that gets to a point where you need, for making cutting-edge science, you need new stuff. So how do you deal with that usually?
Yeah, indeed. If it's cutting edge, then often the UDFs still turn out to be a nice thing. But you also see that, like World Serial, for instance, they still do their whole pre-processing using the standardized processes. And then from the part they still need to do UDFs inside UDFs, there we usually learn from how we need to extend our standardized processing offer. So it's really a nice collaboration and learning from the UDF part. I think that it works quite well, but certainly for advanced cases, you often need it. It's a nice solution to not being stuck, actually.
Okay, so thank you for staying for those who are not ready to take the coffee break now. So I'm going to bring you a little bit from the land where you have been the past presentation to the ocean now. So just making you aware of this activity, the Ocean Virtual Lab, which has been developed over the years, in the last past 10 years. And so we'll show you the status of this open platform that is actually building on a lot of things that are now part of the CDSE, like the Sentinel Hub for Sentinel-2, also Cloud-Fero that are part of the Creodias and the CDSE, where we do the most of the processing. And so the challenge for any application, but including with ocean observation, is that we have more and more satellite data available, more than hundreds of satellites observing the ocean, and we want to benefit from the synergy of this data. So of course the Sentinels, but also third-party mission, like the SWOT, Severi, CFOSAT, how to intercompare also vectorial information with raster like SAR image or SST or ocean color images. And so the Ocean Virtual Lab tools, it's a comprehensive solution for handling and analyzing a vast, complex ocean datasets, to aligning data across time and space, enabling and integrating view of the ocean structure. So it's also to allow researchers to visualize and explore dynamic ocean processes. And it offers a critical insight that goes beyond the static snapshot you will see. And it allows researchers to perform feature-based ocean analysis and to develop more advanced algorithms and test the algorithms. So here I will show you only the online portal, which is the free platform, fully accessible. So there is also a standalone application that I will not show today. But so this one is freely accessible. It's ovl.oceandatalab.com, and it's powered up using open source software, so that people can develop their own portal based on the same technology. So it's data are projected and tiled, and it supports annotation, synoptic charts, derivation. And so you see there are more than 200 different products, a lot of terabytes of image and JSON files, and more are including every day with a new satellite coming. And so the workflow between the different tools. So first, the one I will show is the OVL portal, which is freely accessible online. And this is really to discover and to bring awareness on people using oceanographic data of what is available, what the EO data can provide, and so and bringing them to the level that they can confirm their interest in the data. And if so, then they can download using the link. We have links to the Creodias, but it will be to the CDSE to download the data if they need to download a specific data they want to analyze to make some more complex analysis of algorithm specifically on their computer, or eventually in the clouds on the CDSE. Why not? But then we have also another tool, CScope, that I will not describe, but which is really used to analyze the data in depth and that connect in two ways with Jupyter Notebook to do more in-depth analysis. But for now, we'll talk about the OVL portal online that you can all connect easily, and there are some tutorials on our website. So this is a short video. So in fact, when you arrive to the ovl.oceandatalab.com, it comes to a big map where you have different layers, and so you can click to zoom and pan like in many other tools. And so you can see there are pre-selected sets of products like ocean current, sea surface temperature, and sea surface roughness. And but you can click on the left on product, and you have then access to the hundreds of data. You can tick on the box to display it, or you can also search on the search bar on the top, where you can if you want just sea surface temperature and you don't know which product, then you can discover and realize that there have been some new satellite launch measuring the sea surface temperature or SAR or anything. And then you can integrate it and you can visualize it together. You can move also the layers on top of each other. You can also have a better control of the timeline, which is on at the bottom, to really navigate in time really precisely. And you can also highlight all the collocated data, which are the dates in red. And you can select the different products one by one, and you can order the layer so that you can see exactly and better analyze what you want to do. You can also annotate if you want to highlight some structure that you discovered, like an eddy. You can highlight it, and then after that, it becomes part of your user shape that you can eventually export or import. So you can export in KML, and you can also import KML or GeoJSON files to this interface. And so it helps to really make some analysis of the oceanographic structures by really highlighting, here we highlight the fronts in the chlorophyll concentration. So you see that the representation is really optimized. So there is a pre-processing on all the data to optimize the visualization of the oceanographic features. And then when we display the different layers, we can compare and see how the front has been displaced from one observation to the other. If you click on each single layer, you have the exact time of observation. So sometime in a few hours, there have been a shift and a displacement of the oceanic fronts. So it's the ocean is moving quite fast. So that's why we have a large amount of data, and they come at different time of the day. And so you can also make some synoptic charts with drawing different polygons with different shapes. And here is the link. So if you click on the data, you have the link, the direct link to Creodias to download the data. The same could be done with the CDSE in the future. And so and then it could also be connected to the processing on CDSE if the user are interesting. But for now it's not integrating in the CDSE, but this is something that we could explore in the future. But definitely this is the way forward. So just I will just go quickly because I know we are lacking a bit of time. But I let you discover the interface if you go to the website. But basically, we can display. You have the display of on the bottom of the timeline, which is really able to control really precisely the time and to collocate the data precisely within a few hours. By default, it's daily, but you can be hourly, but also weekly, or depending if you want to create your own mosaic. And if you click on the bottom on the top of the timeline, it shows the white bar on the bottom, which can control really precisely the time. And you see also all the data sets appearing as dots or lines. Here it's only two dots because it's just two SAR images. So I did something wrong. I can go back, but I cannot go forward anymore.
Let us know what you need.
Yeah.
Oh, I think now it's back again. I just need to go forward.
The green button.
Yeah, but I pressing the green button.
Yeah, it's the movie is going. You cannot use that one. Yeah.
Okay, now it's good. So yes, so I will not go into more details on that because I've shown it on the video. We can also do some extraction. Here you see some transect. You can also export the data in Python. For example, if you extract some polygons, you can extract it in a Python NumPy array that they can use in another tool. And also you have some way to mark some hotspot. If you have an interesting area you want to remember for next time, you go on hotspot and you create a hotspot really quickly. And you can also share the data with the permalink, the short link that you can set to somebody else. And then you can also create some C-shot, which is also a very interesting feature or new feature in the tool. It's like it looks like a camera. You click on it and you can extract a small area around what you are looking for, and you can put a title and a description. And when you create it, it aliments a base.
Please note that the plenary session Outlook for ESA's Earth Observation Programs, CM25, will be starting in 5 minutes and will be taking place in Hall D, level -2. Level -2, Hall D. Thank you.
Thank you. I have 2 minutes more, so you will have time. So no, just this C-shot is an easy way to share also something with a colleague, because you can also all the annotation that you have put in the tools, they are present on this C-shot. They will be shared. So when you create the C-shot, and it will be either public if you want to publish it, or just a private link that you send to somebody, and when you click on it, it will open exactly the same as you have on your computer, including the user shape that you have been drawing. And so this is an easy tool to share. And so you see that when you have created your C-shot, you have a possibility to open it or to share it quite easily. And there is a way also to create animation. So you put a beginning and end time, and you can easily create animation over satellite observation that you can share and integrate into your presentation also. And so you can also annotate okay. And so there are many examples. If you go to the website cshot.odl.bzh, so it's also a link directly on the OVL. And so all the feedback are welcome on this forum. We have a forum also accessible. And so with that, I think I will thank you for attending until the end. And I wish you a good coffee break.